So hi, you have been learning stack for matching brackets, finding next greater element and solving histogram problems. Now here's a classic stack application that we need to evaluate the postfix expression, also called as reverse Polish notation. Now instead of writing this, we will write it as 2, 3 plus 5, and stack makes evaluating this trivial. So I'm breaking this video in three parts. First, the intuition behind how it works. Second, the pseudocode. And the third, the real reason why postfix notation exists. Trust me, most people skip this part, but it what makes everything click. So let's start. Now before starting, I wanted to tell you that I upload DSA lectures regularly to help you understand the concept in the easiest possible way. If you find these videos helpful, do like and share and subscribe. So let's begin. Now, this is basically a lead code problem. First, let me take the example. So this is the first example in which we need to find the answer for this expression. Okay. Now, the answer for this is nothing but that, see, this is nothing but the operator of addition. Okay. So we need to take the previous two elements, which is 2 and 1, and we need to find the addition of this. So this will be 3. Okay. So the answer for this is 3. Now we need to take 3 and this 3, and we need to have this multiplication. So if I evaluate this, then it will be 9. So the result of this expression is 9. Okay, let me take one more example. So as I told you that we need to keep scanning. Now when I got this division, okay, I need to take the previous two elements, which is 13 and 5, and I need to find a division of this. So 13 by 5 is nothing but 2. So here we are taking only the integer part, and now we don't need this 13, 5 and division. Okay, it has been replaced with 2. Now here there is a plus, right? So take the previous two element, which is 4 and 2. Okay, so we need to do 4 plus 2, that will be 6. So the result of this whole expression is 6. Let me take one more example. As I told you, we need to keep scanning. Okay, and once I found the operator, the operator can be either plus, minus, multiplication or division. Okay, so here I do see that it is a plus. So we will be taking the previous two elements, which is 9 and 3, and I'll do the addition of this. So for this, I will be getting the answer as 12. Okay, now the next is minus 11. So this is nothing but an element only. After this, I do have the operator, which is multiplication, in which I need to take the previous two elements. Now the previous two element will be 12 and minus 11. So if I find the answer for this, that means 12 into minus 11, the answer is 132. Sorry, minus 132. Okay, now see, after this I got this division, so I need to divide the last two values. So 6 and minus 132. Now if I divide 6 by minus 132, the answer is 0. So for this expression, the answer is 0 from year to year. Okay, now the next operation is multiplication. I need to take the previous two elements, so 10 and 0. So 10 into 0 is nothing but 0 only. I hope you are getting it. So it will be 0. Now 17 is there, it is a number. Now we got plus. Okay, so we need to take the previous two elements. So 0 plus 17 will be 17. Okay, and now there is a 5, so ignore it. Now take the plus. So we need to take the previous two element, which is 17 and 5. So the answer will be 22. So I believe you got it. The result of this whole big expression is 22. Okay, now here comes the intuition that how we will be solving this. Now see guys, when I'm encountering any operator, either plus, multiplication, division or subtraction, I need to take the previous two elements. So I need to have a data structure that stores all the elements one by one, or when I encounter any operator, I need to take the previous two elements. Okay, so here in this case, stack will be very useful. Now some student might say that why can't we use array? Now see, definitely we can use array, but there is a drawback in which we can take the previous two elements. So let's say we are storing 10, then 6, then 9, then 3. Okay, now when the plus arrives, we need to take this 9 and 3, right? But we need to delete that element, and instead of here I need to put 12, and that can't be happen in arrays. Okay, hence I'm taking this stack. So let me take one example and I'll show you that how this is working. So approach 1. Now the example for this is 5, 3 plus 6, 2 minus multiplication. Okay, so let me draw a stack as well over here. Now 5 is there, so basically I will store that 5 inside the stack. Now 3 is there, so again I'll store it. Now when the plus is there, I'll not store that plus inside the stack. I will basically take this two previous element. Okay, now see, if I take this element first and take this element, okay, now I will be doing the addition of these two, okay, which will be 8. Now as we know that some operators do follow the commutative property, that means a plus b is equals to b plus a. Okay, but this will only be true for some operators, not all the operators. So we need to take this value and store it in n2. Let's see, if I want to do n1 operator n2, okay, and the result. Now I will be popping this element and store it in n2 instead of n1, and again I will be popping this element and storing in n1 instead of n2. Okay, I believe you got this. Now I'll take this 3, basically I'll pop it, and I'll take this 5 and I'll do plus. So the answer for this is 8. Now since I popped it, now the result of this will be pushed back into the stack, which is 8. Okay, now I got the answer of this. Now 6 is there, so I'll push it. 2 is there, I'll push it. Now I need to do minus of 6 and 2. So I'll pop this 2 and 6. Okay, now 2 will be in n2 and 6 will be in n1, and I need to do minus of this. So this will be 4. So I'll push back 4 into the stack. Now there is a multiplication, right? So I'll not push multiplication into it. Instead, I will be taking this 2 element. So 4 will be here, 8 will be here, and I need to do multiplication of this. So the answer will be 32. Okay, this will be get popped, and here 32 will be get pushed. Now after this, at the end, we need to return what is there inside the stack. So in the question, in the LeetCode question, they are saying us that the reverse polish notation or the postfix expression is the valid one. Okay, so after evaluating this, we will be getting only a single element inside the stack. So we need to return that, and that will be your answer. So I hope you got this. Now let's begin with the pseudocode. Here the name of the function I am having is reverse polish notation. Okay, in which they are basically passing the string array. Okay, the name is tokens. So these are nothing but tokens. Okay, and all these tokens are basically a strings. Now since I will be using a stack, so let me create a stack using Java. If you are a Python, C++ or any other programming language developer, you can figure it out on your own, or basically you can Google it. So let me first create it. Now see guys, I do know that inside this token strings are there, okay? But when I'm storing that string inside the stack, I will be converting it into the integer, so the operation will be simple. Hence I have written integer over here. Now for, since I want to traverse for each and every string, so string token tokens. Over here I have used enhance for loop. Now if I do get the operand, that means the element, basically I will convert that string into a number and I'll store it. But what if there are operators, that means plus, minus, and so on? Okay, so over here, if token is equals to plus, or token is equals to minus, or token is equals to multiplication, or tokens is equals to division. Now basically, instead of this, I will be using dot equals. In Java, basically we do have this method. Now to make it simple, hence I've used this operator. Okay, now first I will pop the element, and that element will be stored in value 2. So st dot pop, and the second element that I will be popping will be stored in value 1. Okay, now I will be making a function in which I will be passing value 1 and value 2 and the tokens. Okay, if it is plus, minus, multiplication, or division, and that function will be going to return me the result. So the name of the function is do operation, in which first I will be passing value 1, value 2, and the token. Now see, the token is nothing but a string. Okay, and that string contains only one value, right? So token dot char at 0. Okay, I can't simply pass that whole string even though it contains only one character, but I will do this. Now whatever value that I will be getting from this function, the result, right, I need to push it back. So I'll have st.push. Okay, and that's it for the if case. But what if instead of the operator I do get operand? So in the else part I need to just push it. So st.push, first I need to convert it into the integer. So integer dot parseInt token. And that's it, we are done. Now by the end of this for loop, we will be getting one element that is stored inside the stack, and that element will be the result. So return st.pop, and we are done for this problem. Now if you want, you can try run it by yourself. Okay, now talking about the code performance of this algorithm, the time complexity is order of n, because we can see there is only a single for loop. Okay, and the space complexity is order of n because we have taken the extra space in the form of a stack. Okay, now let's have this do ops. So this function basically return the integer value, right? So int do operation, in which it is taking value 1, value 2, and since we are converting it into this, so obviously it will be a character now. So char operator, either it will be plus, minus, multiplication, or division. Now see, there are 4 choices, either plus, minus, multiplication, or division. So I will be using the switch case over here. So switch, in which operator Now there are 4 cases. So case 1 plus. If it is plus, then I need to basically do value 1 plus value 2, and I need to return that value. So return value 1 plus value 2. If it is minus, so case minus, return value 1 minus value 2. For case multiplication, return value 1 value 2 into value 2. Okay, and since we are returning the value, guys, hence I don't need to have a break. And there is a last case, division. So return value 1 divided by value 2. So I hope you got this. Now, for the formality, I need to write return 0, even though the expression is going to be a valid one. So I will be not touching this last line, which is return 0, which is this. Okay, but for the formality, I am writing this. So the time complexity of this whole algorithm is nothing but order of n time, and the space is order of n. Okay, I believe you got this. If you haven't, please try run it by yourself. Okay, now the purpose of the postfix or reverse Polish expression, that why instead of infix 3 plus 4 into 5, we tend to go for postfix notation. See, in the normal infix expression, computer needs extra rules to decide which operator should evaluate first. We also need some parentheses to remove the ambiguity. And the postfix expression, also known as a reverse Polish notation, solve this problem completely. In postfix, operator comes after operands like 3, 4, 5, multiplication, plus. This remove the need for parentheses and operator precedence rule. The expression can be evaluated directly using a stack by always applying the operator to the last 2 operands. That's why postfix expressions are widely used in compilers, interpreters, and calculators for efficient and unambiguous expression evaluation. Okay, so that is the reason that the computer use the postfix expression instead of infix expression. Okay, so I believe you got this. So if this lecture helped you understand this concept better, make sure to like the video, share it with others who are learning, and don't forget to subscribe for more easy DSA explanation. I thank you so much for watching till the end. I'll see you in the next lecture. Till then, keep practicing.